Hi class, I'm going to talk in this video about how to simplify monomial expressions. I went ahead and already showed you the different combinations to get 60 because that is the first step. This is the same thing that we've learned in the past. So that's basically the first thing that you want to do. You want to simplify the number that's inside of the radical. So I'm going to go ahead and explain to you guys. I'm actually going to show you two different ways. I'm going to split this up. The first way is way up top 4, and the second way kind of goes with what's on the right hand side there. So I'm going to write the square root of 4. I'm going to make this a little bit longer because there's stuff that I'm going to add to it later. Times the square root of 15. Okay. Now the next thing I want to do is I need to move the variables over to determine if I'm going to put them on the left side or on the right hand side. Well, a clue for you is that if there is an even number as an exponent, the entire variable is going to move over to the left hand side because that is an even exponent. And in the second part of this video, I'll show you why that works. But anytime you see an even number, please put that in the left hand side because we're going to be able to simplify it. Now, b to the 7th, if I split this up, I'm going to b to the 7th equals two numbers that I can multiply. That'll give me 7. So really what I'm going to be doing is adding the exponents here. I want the highest even number to get like blank plus something will give me 7. And that highest even number is 6. So I'm going to be splitting up 7 into b to the 7th power to b to the 6th times b to the 1st. Okay, so basically 6 plus 1 will give me 7. That's how I know I've split that correctly. Notice how this is an even number. This entire variable is going to go in the left-hand side because remember I said I want all the variables that have an even exponent on the left-hand side. Then b to the 1st is not even. That's left over. So that's just going to be placed in the second radical. Alright, so now what I'm going to do is just simplify everything that's inside my left radical. Square root of 4 is 2. The square root of a to the 4th power, you're probably like, okay, how do I do this? Really, there is a 2 sitting out there in the radical because it's the square root. And I'm going to take the 4 and divide that by 2. So really, I'll have a to the 2nd power and b, so b sorry, not b, 6 divided by 2 will give me 3. So I have what I've simplified on the left hand side already done. Multiply that by what's left over. So this is my final answer when simplifying this monomial. So just to recap, you want all the even exponents on the left-hand side because we're going to be able to divide that by 2 and get an integer. 15 and b to the 1st power are those I can't simplify anymore. If I do 1 divided by 2, that's not an integer, so I'm going to go ahead and keep that in the non-simplified radical. And then here I have everything. If I find the square root of 4, it's 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Now, where are all those numbers coming from? I want to explain to you that this is like the longer way, but it's a process which kind of explains where all these numbers are coming from. I'm going to go ahead and expand this portion on the right hand side. Okay, so I've expanded this for you guys. I use 4 times 15 because I already know that that's the number that I'm going to use as a highest perfect square and my non-perfect square there. I've expanded a to the 4th power and b to the 7th. Now, just a reminder that there is a 2 in front of that radical. So basically, I want to find groups of 2 and box them in. Well, 4 and 15, and I'll leave those aside because that's a different process. But I can box in A, these two, I can box this, but I'm left with 1. And some of you guys are like, oh, I kind of see what's going on, because if we look here in our answer, we had 15 times b to the 1st power. Notice that I'm not circling that because there's no other b. So what I'm going to do now is the same process I've done before. I'm going to write the perfect square on my left-hand side. So my non-perfect square over here. But that b that's left over by itself, I'm going to put that in the non-perfect square because I can't simplify that even more. Now, where these exponents are coming from, hopefully some of you have noticed the pattern. Now, here if I look at my a's, I've circled two groups of a. So I have two groups. I'm going to show you that what happens in a little bit when I simplify that. But I have 4 a's in total. Then I have 6 b's in total that I've boxed in. When I simplify them, the exponent is going to tell you how many groups of each you have. Okay, so the square root of 4 is 2. That's an easy one. The exponent for the letter A, again, is how many groups that you put together, and I put 2 groups. I have 2 sets of A's here. So that's where that number is coming from. With B, I've circled 3 groups. So my exponent is going to be b to the 3rd power times the rest that cannot be simplified. Notice how these two answers are the exact same. So you can just choose which method you prefer. I know that some of you guys would prefer the shortened version, but it's always good to understand why it happens the way it is. Like why do I divide by 2? Well, those 2, what that 2 means is basically how many groups are you clumping together. All right, so let's see if we can try number 1 here so that I can show you a little bit more when it comes to the radicals or the exponents here. All right, so I'm ready to start this problem. Don't forget about the -2. That's going to come into play at the very end. But what I want to do is highlight all my exponents here. I have 3 and I have 14. Remember, we are trying to find even exponents and placing them into the left-hand radical, and then whatever's left over will go on the right. So x to the 3rd power, if I were to split up x to the 3rd and have my highest, or the highest even number, that's going to be 2. So on the left-hand side, I'm going to have x squared, and then on the right-hand side, I'm just going to have x, which is my leftover. Because if I add 2 plus 1, I will get the exponent of 3. Now, y to the 14th is very easy because we can just place that all in the left-hand side because that's an even number. What I'm going to do now is divide everything by 2 because there is a radical, the symbol outside of the radical, or the index, is 2. So everything is going to be divided by 2 in order to simplify the left-hand side. So this is what I have so far. -2 times x times y to the 7th times the square root of x. So this is your final answer. You can write it as -2xy to the 7th times, or square root of x. Doesn't matter, as long as you know that all of this is being multiplied together. All right. I'm going to go ahead and try number 2 really quickly for you guys. And here we go. All right, so those are the different combinations in order for me to get 48. I've underlined the perfect squares, but there's only one combination that I can use, which is 3 times 16. So I'm going to place the 16 inside of my first radical because I'm going to be able to simplify that. And my 3 is going to go ahead and be in the second radical. Now remember, if you have an even exponent, we're going to place those inside the first radical here. So a, unfortunately, is not even. That's an odd number because it's a to the 1st. So I'm going to put that in the blue because there's nothing I can simplify that. It's already simplified for me. B to the 2nd will go in the left-hand side. And then c to the 7th, remember we can split these up if it's a high enough odd number. So c to the 7th, if I were to split it up, I'll have c to the 6th on the left-hand side, and the remainder c will be on the right. So now what I'm going to do is simplify this radical. Square root of 16 is going to be 4. And remember, there's an index of 2, so everything that has raised to a power will be divided by 2. That's why we want an even number. b to the 2 divided by 2 power is just b to the first, or b. C to the 6th power divided by 2 is c to the 3rd power. Then bring down the remainder. Everything inside that radical cannot be simplified anymore, and there's your final answer. Okay, so again, make sure you remember that when you have these bigger, larger, odd exponents, you can split them up so that you can have even numbers and then just divide by that index. In this case, all of our indexes were 2, but there are some examples where you will have to divide by 3. I don't think I have an example here, but just be aware of that in the future. Okay, well, let me know if you have any questions, and good luck solving these monomial expressions.